Hi, Galeno. So we are looking at question 39 on page 156. This is it from the textbook. I just did a quick copy and put it here in the smartboard. So this type of question is probably one of my favorites. And it's because there can be so many varieties. So really what you have in this question is you have two objects. They're connected with a string, and there's some kind of movement. So there's acceleration, and in this case, we can assume that the weight here is pulling everything down. In some cases, it's not going to be moving because the mass of whatever the object is going to be on the surface might be, too heavy, or the friction might be too large. But in this case, we have wheels and the weight is pulling everything down. So there's a few things that you kind of have to pay attention to. Um, uh, there, there's a force of tension. So there's a force of tension in this rope, and we're not going to specify certain directions because for the different objects, force of tension is going in different directions. But we can assume, or not even assume, this is true. This tension in this rope is the same all the way through. That's what they have in common. So that's going to be one of our kind of bridging pieces of information between the two objects. The acceleration, it's going for this weight here. It's going in this direction, so it's going down. For the cart, it's going to the right. So that's kind of what we're trying to calculate in this question. I'm going to calculate part B, and I'm going to let you try part A. Part B is just a little more complex because you have a friction force introduced. But part A should be simpler because you don't have the friction force. It's going to be the same method, but I'll let you try it, and if there's any difficulties, just send me a message and I can solve that one too. So this is how we approach this type of question. We are going to create a free body diagram for both of the objects. So I have the cart. Here we go, cart. And we have the weight. There we go. So if we're looking at the cart, here's my object. There's a few forces acting. So I have the normal force. I have the Fg. So I'll write this out right away that this is mass of the cart times the acceleration due to gravity. It's not really going to come into play with the cart, but I'll just write it out. So these two cancel each other out. They're not really, they don't have any kind of influence on the acceleration. The other two forces that are important is we have the tension force, which is going to the right, tension, and then we have a force of friction that's going to the left. So force of friction like that. There we go. We have an overall net force that is going in this direction. So F net, I'm going to put C for cart. That is also the direction of acceleration. So that's the cart. Then we're looking just at the weight. The weight is going to be very similar. Here's the weight. We have Fg. So this would be Fg for the weight. So maybe I'll put FGW, and this is going to be FGC for the cart. So in this case, FGW is mass of the weight or object, and times the acceleration due to gravity. Second force is going to be the tension force. So in this case, the tension force is going up. And I'm not labeling it as a tension force for the weight or tension force for the cart. It's the same tension force. All right, so that's it. So you create your free body diagrams. Whenever you have questions like this, you create separate free body diagrams, and now you start looking at the net force for each one. And then we're going to go from there. So I'm going to go to the cart first. Like I said earlier, normal and gravitational force are canceling each other out. We know that F net in this case, or in any other case, so F net C is mass times acceleration. So in this case, it's going to be mass of the cart times the acceleration. And it's going to be the same acceleration between the cart and the weight because they're connected together. We can also express F net, net C, as a sum of all forces. So in this case, we have the two forces that are creating this acceleration, which is tension and force of friction. So because the cart is going to be moving to the right, I'm going to express it as tension force minus force of friction. So like this. So we have two expressions for F net for the cart. So what we can do is we can actually make these two equal. So I can say, okay, tension minus force of friction is equal to mass of the cart minus the, not minus, just equals mass of the cart times the acceleration. There we go. So that's what we have right now with the cart. I'm going to go and move to the weight, and I'm going to do the same thing. I'm going to find the F net for the weight or object, as it says in the question. So we have, again, F net of the weight is mass of the weight times the acceleration. And also I can express the F net of the weight as the sum of all the forces. So in this case, we have two forces, which is the gravitational pull and tension. Because the acceleration is going in the downward direction, I will take the FGW minus the tension force. There we go. So similar to the cart, it's a little bit simpler because there's not that many forces that you have to kind of keep track of. And then we're going to do the same thing. Because the net force for the weight can be expressed in two different ways, we can make them equal. So we're going to put it as FGW minus FT is equal to mass of the weight times acceleration. So if we look at the two expressions that we have for the cart and for the weight, we can kind of do a little quick checklist of what we actually are given in the question. So let me go back up here. So we have a few things. We have the force of friction, that is 0.6 newtons. What else do we have? We have the mass of the cart, which is 2.3 kilograms. We have the mass of the weight, which is 1.7 kilograms. We do know that acceleration due to gravity is just 9.8 meters per second squared. And that's pretty much it. We are looking for acceleration. All right, so if I do a quick checklist. Okay, I don't know what the tension is for the cart. I do know what the force of friction is, so kind of check that off. And I do know what the mass of the cart is. Good. I don't know what the acceleration is. That's what we're looking for. Then I'm going to the weight. I do know what the FGW is going to be because if you remember, the FGW is actually equal to the mass of the weight times the acceleration due to gravity. So I can calculate that. That's actually pretty easy. So I have that. I don't have the tension. I do have the mass of the weight, and I don't have the acceleration. So what you have here is actually a system of two equations. We have two variables and we have two equations. So what we're going to do is, because if you remember again at the beginning, I said that the tension is going to be that bridge between the two objects. Because we're looking for acceleration, we're going to express both of these equations. We're going to isolate tension. So in this case, it's going to be Ft is equal to mCA plus force of friction. And then we're going to do the same thing on the other side. So Ft is going to be FGW minus MWA. There we go. So now that we've isolated Ft, we can combine them together and make them equal to each other. So Ft from the cart is equal to Ft from the weight, and we're going to make them equal. So Ft from the cart is mCA plus FF, and on the other side it's FGW minus MWA. There we go. All right. We have everything but the acceleration. So we're going to isolate. We're going to move all the terms with the acceleration to one side, everything else to the other side. So I have MCA plus MWA is equal to FGW minus force of friction. There we go. I'm going to factor out A, acceleration, which is what we're looking for, which is going to leave me with MC plus MW, and that's going to equal to the same thing. Actually, you know what? I'm going to just adjust it. I'm going to change the FGW, and I'm just going to replace it with MW times the acceleration due to gravity, and still just force of friction there. And now to isolate A, we're going to divide both sides with this bracket, essentially, MC plus MW, which means that acceleration is going to be equal to this. There we go. All right, that's it. So at this point, we're just going to substitute everything. There we go. So my mass for the weight was 1.7. There we go. 1 point, oops, not 1.8. 1.7 times 9.8 minus force of friction was 0.6. And then we have the cart, which is 2.3 plus 1.7. We're going to punch this in the calculator, and we're going to get 4.015. There we go. And if we round this off, it should be around 4.0 meters per second squared. There we go. So that is going to be acceleration for both objects. For the cart, it's going to be moving to the right, 4.0 meters per second squared. For the weight, it's going to be moving down 4.0 per second squared. And that is the solution for this type of questions. So if you need any other explanations, email me. Try part A. The only difference for part A is going to be when you're doing the cart net force. So in this case, where we had the tension minus force of friction, there will be no force of friction. So it's just going to be that F net is equal to Ft, and that's going to make things a little bit easier. The weight is still going to be the same thing. So you're going to make them equal again, just like we did, and solve it and get some kind of an answer. And that's it.